Hello everyone, welcome to McDraft and Strength. Today's session is on epicycloid. So with the help of short video, you will understand what epicycloid is in the simplest way. So let's start. Okay, so here in animation, there are the two circles. One circle, it is a big one circle, it is a fixed circle, doesn't move. And another is the rolling circle, that's a small circle. It rolls on the outside of the fixed circle without slipping. And there is one point on the circumference of rolling circle that traces the epicycloid. Means what the means of epicycloid? The curve traced out by a point on a circumference of rolling circle as it rolls around the outer side of the another fixed circle. That is known as the epicycloid. So let's see how the question may ask in exam. In this question, the rolling circle diameter is given and the directing circle diameter is given. So the rolling circle, it rolls over the another, and directing circle, it is a fixed circle. So the rolling circle, whenever it rolls on the directing circle, so it covers the distance circumference of the circle, means pi d. Okay, so here we calculate the pi d, it comes 189 mm. And for directing circles we need angle. So for angle, you have to remember this formula: 360 into small r divided by capital R. Small r here, it is the rolling circle radius, and capital R, it is the directing circle radius, and the calculation comes at 135 degree. So let's see how the actual construction occurs. First of all, draw an arc of radius 80 mm, that is directing circle radius, and subtending angle of 135 degree, and mark the center as O. Next step, draw a rolling circle diameter of 60 mm and mark that center as CO, and in such a way that it's touching the outside of the directing circle at point P. Next step, draw an arc with the center O and CO as a radius. So this arc represents the locus of the center of the rolling circles, and divide that arc into 12 equal parts by drawing radial lines through the center O, and mark that point as C1, C2, C3 and up to C12. Now divide the rolling circle into 12 equal parts and name the point as 1, 2, 3 up to 12. Now with center O and radius equal to O to 1, draw an arc. Again with center O to 2, draw an arc, and repeat the same procedure for remaining points. So the next step is make sure that in your compass you have to take a distance is equal to radius of rolling circle, that is 30 mm, and with center C1 and radius is equal to 30, draw an arc to intersect with arc line which come through point 1 and mark that point as P1. Again shift the center to C2, mark the arc line which come through point 2, and repeat the same procedure for remaining points. And the last step, join the points P1, P2, P3 up to P12 by a smooth curve to get a required epicycloid. Hope you like the session. If you like this kind of content related to engineering subject, so subscribe my channel so you don't miss next one. Thank you.